Hello, everyone. Good morning. Respected authors and invited guests, welcome to the technical session 2D. Myself, Gayatri Burguda, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, in Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from the 9th to the 11th of April 2026. I hope you all will enjoy the knowledgeable session throughout the day. In this session, we'll be having 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. Upon 9 minutes, I will raise a gentle reminder. There's a request to all the participants that you all stay connected with us till the closing remarks. If you have any kind of query or doubts, please make sure you text me in the chat box. Just before we start the session, I would like to introduce you all to the session chair. Dr. Tarun Kumar is an associate professor in the School of Computer Science at the University of Petroleum and Energy Studies, Dehradun, Uttarakhand, with more than 20 years of teaching experience. Specializing in cloud and DNA computing, his research interests include cloud computing, IoT, and DNA computing. He has published several edited books, book chapters, patents, and research papers in conference proceedings and referred journals. Now, I would like to start with the papers. I'd like to call upon our first presenter, Mr. Abhishek Chaudhary, to present his paper titled An Accessible and Safety-Aware AI-Driven Digital Mental Health Platform for Visually Impaired and Multilingual Users. So you may start presenting.
Yes, give me 1 second. I'll share my screen.
Yeah, sure.
Is my screen visible to all?
Yes, sir, it's visible. You may start.
Yes. So, hello everyone. My name is Abhishek Chaudhary, and today I will be giving you all a conference presentation on my topic: an accessible and safety-aware AI-driven digital mental health platform for visually impaired and multilingual users. So, talking about my project. So, firstly, my project is an sponsored project which I did from with the help of this company. As you can see on the screen, EMsphere Technologies. It is an Indian IT software company which works on the workforce management and HR automation solutions. So, we like made the project for them. So, this is the information which you can read from the slide. So, moving on to the presentation. As you can see, I've shared the. I will be explaining on these few points: the problem statement, motivation, and going to the references. So the problem statement here comes is that in as this is a sponsored project, so for the company, like we had a discussion with the company MD, and then we got to know the problem statement was that the employees which work in the particular company, they are not able to like express their mental health feelings to the particular manager, or else the particular their who they are reporting to, the HODs or the managers and all. So I've made a mental health chatbot system which helps the manager to get to know what exactly the employees or else the people who are working under them are facing through. So this is the main problem statement as we can see. Then comes the motivation. As we can see that rising global mental health challenges are there. Many individuals avoid therapy due to stigma, cost, and lack of ability of multiple doctors, or not able to express freely in front of others. Then, I've done a few literature survey on a few papers, and then I've got to know that the existing chatbots lack some safety mechanism like crash detection and all. Then there was a need of these assistants who have built this mental health chatbot. Then come the objectives. So the objective was to develop an AI mental health platform, a multi-therapeutic persona modeling. I have used 8 persona modelings. I'll explain it in the next slides. Then I have done mood analytics, crash detection is done, and multilingual and voice accessibility is also there in this chatbot. Then comes the scope, as I mentioned about earlier. Then these are the 8 research paper which I have gone through, and I've done the study of these 8 research paper. So their key contribution, as you can see, for these four specific research paper is that The first one is a conversational support, then second one provides the emotional support, then the third one is the CBT techniques through anxiety management only. And the fourth one is that it is through multilingual chatbot. So where the lack was mood analytics, crisis detection was not there. As crisis detection means that if a person is like, for example, if a person sends a message to the chatbot that I want to suicide, then a particular crisis detection must be done on this point of view, because it comes in a safety point of view. Then comes therapeutic diversity, analytical tracking and monitoring of the employees, as I said. And then comes lack of the crisis detection in the fourth paper also. Then moving on to the next four papers, you can see that there was risk of hallucination, safety concerns was the main problem. Then mood tracking also was not there, and they have used a few LLMs and all. So the common gaps were like therapeutic diversity, lack of mood analytics, crash detection was not there, accessibility features were also in poor in the few of the projects, and longitudinal monitoring and absence of professional reporting. So moving on to what I have made now. So first, I have made a AI-driven digital mental health platform in which I have given multiple therapeutic personas. Like there are total 8 therapeutic personas. I will show the images. Then comes a mood analysis framework, and then comes the analytics dashboard, which the manager can download the, as in, for example, if an employee, like I'll explain in the next slides. Then comes the crisis detection, multilingual and voice-based system. And we can generate, like you can see in the third point, we can generate periodic well-being reports to summarize the mood trends, which the manager can do. Like see, you can see that for allowing the managers or HR teams to identify the stress patterns and improve their workplace interventions. And also data privacy is also taken care of. So as you can see, this is the main system architecture diagram of my project: the front end, the back end, the AI integration layer, and the database layer. So what the front end, what we can see is that there is multilingual support. It is supported on web and also on the mobile interface. Also has voice input and output also. Then comes the analytics dashboard. On backend, I have used REST API like Node.js, Express.js, and crash detection engine is there. Authentication, JWT is used, and Decrypt is used for the authentication purpose. And session management is done. Like as in, like for example, referring to Chat GPT, like how they store the our chats. That same my chatbot also stores with the help of MongoDB, you can say. And then the AI integration part comes. The Gemini LLM I have used here as an AI part. Then comes the persona modeling and the mood analysis, and then everything is stored into the MongoDB user session and the mode data. So here is just the implementation part, like just as I explained it in the system architecture. So moving on to the main part, which is the chatbot. So as you can see, here are total 8 personas I have taken here, general psychologist, and these 4 to 5 are the people who are a mental health therapist in real life world. So I have taken their research paper, and according to, with the help of their research paper, I have extracted the data which we can refer to it, and the person who is using the chatbot can refer to them. Then comes the cognitive behavioral therapist, which gives exercises and all everything to it. Then comes the inner child therapist. Like for example, if sometimes I like my inner child, I have to express my inner child person. Then I am not comfortable to do it with people, so I'll just share it with the chatbot. And then comes the mindful therapist. So as you can see that in this chatbot, I have attached a screenshot. Like I have just said that I am stressed and one second. Sorry. I have stressed, and then it gives a like as an answer to it. Then it not just gives a like as a solution to it. It digs deep upon into the what the main problem is. Then like you can say I'm stressed a lot. Then it tells like I hear you, I can feel it, it's a lot, you are carrying heavy weight and everything. Then this is the main chatbot conversational. Then here is the multilingual, which you can see on the right side of the column. As this was built in India, so I've taken 10 different Indian languages like English, Marathi, Hindi, Gujarati, Bengali, and everything, as you can see in the image. Then come, this is the example, I've taken it in Hindi. Then you can refer it to it. It is a multilingual example. And then this is the main dashboard. So what this dashboards mean that the manager will look into this dashboard, and then he'll do the average mood analysis of the that particular person. So here you can see I've given a last 30 days, like you can know, like you can calculate for 7 days, 30 days, 90 days, and there is also custom range. So this is the score which is calculated on the basis of, with the help of, like Gemini gives the score, and I've displayed it here. And for every score less than 6, it does not give any therapy or else remedy. And every score greater than 7, oh sorry, 6, it gives a remedy. Like you can see here, view remedies are there. Then we can create the report. Then comes, this is the like just a graph, as we can see if the and well-being index of then the main what you can say is that the main analysis I've done with four major parts: anxiety, stress, depression, and well-being index. Well-being index is the good part. So this shows negative because I have just like tested it with help of some negative, like I want to suicide for the crisis detection, which I'll show, and the suicidal thoughts, stress, anxiety. That's why the score is negative. Then this is the safety, accessibility, and reporting part in theory part. You can see, and here is the crisis detection. Like if someone like as in says that I want to suicide, I'm not having like the I don't have the willpower to face anything as of now, and I don't want to live anymore. Then crisis detection is here, and then the helpline numbers are immediately given up, and you can just contact them. So, talking about the results part, the system performance result shows that the chatbot response performance is there, user interaction efficiency is there, and system stability is there. Then comes the mood analysis dashboard, crisis detection system, and the accessibility features. And the main result part, as in the evaluation part I did, was in my university. I just give the like as an access of the chatbot to 50 students, and they in the duration of 2 weeks they gave me these results, which you can show here. You can see here. The time analysis processing was approximately 3.4 seconds per study. Crash detection was detected in less than 500 milliseconds. Then retrieval time is approximately 800 milliseconds to 1 second. Then the PDF is generated in 2 to 3 seconds, and the overall satisfaction of the project was 4.6 out of 5. This was the main evaluation part. Um, so now this part shows the conclusion. This is the conclusion, and the so as you can see, so this project is like a conversational AI chatbot. It helps to interact with the like as in emotional well-being, receive supportive guidance from particular people, and also key features such as therapist personas and crisis detection, voice accessibility, and analytics dashboard. So, um, so these are the references which I've used. That's it. Any questions, sir, ma'am? Anyway,
Thank you so much for your presentation, sir. You may now stop presenting.
one sec.
I would now like to call upon our next presenter, Shaklo Rustamovna Abduleva ma'am, to present her paper titled Artificial Intelligence as a Tool for Improving Participatory Budgeting in the context of the digital transformation of Uzbekistan economy. Ma'am, can you please start presenting?
Yes, good afternoon, dear participants in conference. May I ask, do you see my presentation?
Yes, ma'am, your screen is visible. You may start.
Okay. Thank you very much, and for this opportunity to present our research. And today I will talk about the use of artificial intelligence to improve participatory budgeting in the context of the digital transformation in our country, in Uzbekistan. First of all, I would like let briefly describe the current stage of digital transformation in our country. The government is actively implementing the Digital Uzbekistan 2030 strategy, investing around $2.5 billion in digital infrastructure. As a result, digital public services have significantly expanded, and Uzbekistan has improved its position in international rankings. For example, the country has risen in the United Nations e-government development index and is now classified among countries with a higher level of digital development. At the same time, the ICT sector is growing rapidly. Employment increased from 62,000 in 2020 to almost 88,000 in 2023. However, challenges still remain, including a shortage of qualified specialists and relatively low digital literacy in some regions. Industry digitalization is becoming increasingly prominent in Uzbekistan's digital economy, playing a growing role in its overall structure. Against this background of digital transformation, improving public administration becomes a key priority. In particular, special attention is given to increasing transparency and efficiency of the budget process. One of the most important tools in this area is participatory budgeting. This mechanism allows citizens in our country to directly participate in proposing projects, selecting priorities, and monitoring the use of public funds. In Uzbekistan, participatory budgeting has been actively developed since 2018, together with the launch of the Open Budget platform. The shift from the traditional approaches to budget allocation toward more interactive and technology-driven mechanisms has become an objective necessity. In academic literature, participatory budgeting is considered an important instrument for improving public trust, increasing transparency, and better understanding citizens' needs. The results in Uzbekistan are quite impressive. Over the past few years, funding for participatory budgeting has increased more than 12 times, reaching almost 6.7 trillion soms by 2025. Thousands of projects have been implemented, mainly in areas such as road infrastructure, street lighting, and education. However, despite this progress, several challenges remain. Uneven participation across region, limited involvement of private sector, and the lack of advanced analytical tools for decision-making. At this stage, traditional approaches to budget allocation are no longer sufficient. There is a clear need to move toward data-driven and forecasting-based models. This is where artificial intelligence and big data technologies can play a crucial role. Proposed solutions are artificial intelligence, big data technologies, financial modeling, digital platform integration. In our research, we propose an economic and mathematical model for participatory budgeting. This model links socioeconomic indicators with budgeting outcomes and is based on data from the Open Budget platform. The main goal is to determine the optimal allocation of budget resources in the medium term. The model includes an optimization approach based on the knapsack problem and machine learning methods such as gradient boosting to improve prediction accuracy. From practical perspective, this approach allows us to forecast budget expenditures, evaluate the effectiveness of the projects, and optimize the allocation of limited financial resources. As a result, it helps reduce inefficient spending and improve decision-making quality. From practical perspective, this approach allows us to forecast budget expenditures, evaluate the effectiveness of projects, and optimize the allocation of limited financial resources. The findings of studies show that this approach makes it possible to move beyond of mechanical distribution of funds toward a system of managed and data-driven civic participation. In addition, the model can be used to estimate the impact of regional economic growth and simulate different development scenarios. Overall participatory budgeting in Uzbekistan demonstrates stable growth and strong potential. The integration of artificial intelligence can significantly enhance its effectiveness and support the development of model digital state. To enhance the social effectiveness of participatory budgeting, the study proposed the development and implementation of a big data analytics algorithm within the participatory budgeting framework. Such an approach would enable a transition from predominantly subject and voting mechanism to a more objective data-driven system of project evaluation. This shift is expected not only to improve the efficiency of budgetary resources utilization, but also to strengthen public trust in government institutions. Thank you very much for your attention. I will try to be very short, and I'm happy to answer your question. Any question?
Thank you so much, ma'am, for your presentation. So do you have any questions?
No, ma'am, it's okay. Thank you.
Thank you very much for your attention.
Now I'd like to call upon our next presenter. I would like to call upon Sir Michel de la Ventura to present his paper titled Computational Reconstruction of Missing Notes in Polyphonic Music Using Bigram-Based Entropy Models. Sir, can you please start presenting? Okay, I assume Sir isn't present right now. We can move on to our next presenter. Roshna Dhakal ma'am to present her paper titled Cybersecurity Challenges in Intelligent Railway Systems, a review of ICT architectures, threat models, and AI-based defense approaches. Ma'am, can you please start presenting?
Hey, hello, am I audible?
Yes,
Hello?
you're audible.
Okay, can you see my screen?
Yes, it's visible. You may start presenting.
Okay. So hello everyone. Thank you for being here. My name is Roshna Takal and I'm a computing graduate from the British College in Kathmandu, Nepal, and which is affiliated with Leeds Pickett University in Leeds, UK. I conduct research under the supervision of Associate Professor Professor Khanista Nami from King Mangal's University of Technology, North Bangkok in Thailand, who is also the corresponding author on this paper. Today, I will be presenting our review paper. It's not self-experimented, but it's a review paper on cybersecurity challenges in intelligent railway system, covering how modern railways are built, how they are being attacked, and what AI can do to protect them. This work was funded by the National Science Research and Innovation Funds and King Mangas University of Technology, North Bangkok. So now moving towards the presentation overview, here is a quick roadmap of what I will cover today. There are 8 sections, moving from the threat pictures through the architecture and vulnerabilities to AI defense and our research roadmap. So let me start with the simple question that arises like how many of the people took train this year, or almost every aspect of the journey of the train is controlled by the digital system, and those systems are increasingly under attack. Between 2017 to 2022, cyber attacks on railway system increased by 220%. It's not 20%, but it's 220, and railways now represent 11% of all reported cyber incidents in the European Union. Now, 75% of these attacks are distributed denial of service DDoS, flooding system until they crash, and over 54% of industrial environments, including railways, have been hit by the ransomware. What accelerating this right now is the geopolitical conflict and AI-powered attack tools that make even unsophisticated attackers dangerous. Now, our paper addresses 4 research questions like what are the primary attack surface in railway ICT architectures, what threat models apply, which AI and ML method work best for detection and defense, and why is deployment so difficult. We make 6 contributions. a unified three-pillar framework linking ICT architecture, threat and AI defenses, vulnerability taxonomy, mapping the attack vectors into the communication-based train control systems, ECTS and SCADA, real-world incident analysis from 2021 to 2024, and AI ML benchmark comparison, a deployment challenge analysis, and a prioritized research roadmap. So methodologically, we conducted about review starting from 59 candidate papers across IE Explore, Springer, ACM, and authoritative sources like INISA and NIST. After screening, our final set was 22 high-quality papers. To understand the vulnerabilities, we need to understand the architecture first. So modern railways run a 4-layer stack, and the connectivity between layers is exactly what creates the security problem. For example, the layer 1 is the control center, and we need to understand the architecture. Modern railways run a 4-layer stack, and the connectivity between layers is exactly what creates this security problem. Layer 1 is the control system, and layer 2 is a wayside infrastructures, signal interlocking system, radio block centers, and balises. This transponder embedded in the tract that send position to the passing trains. So layer 3 is a communication network, and this is the most vulnerable layer. The GSMR uses AFI1 encryption that was cryptographically broken since 2010 and is still in use. The industry is migrating to 5G FRCMS, but the transition window where old and new coexist, it is itself a new attack surface. So layer 3 also includes the IEEE 802.11 Wi-Fi and optical fiber backbone, and layer 4 is an onboard system that consists of ATO, ECTS. The critical insight is that a breach at any of the single layer creates a cascading attack path through the entire system. Okay, now let's move towards the key vulnerabilities. The 3 operational systems have the 3 distance vulnerability profiles. The first one, that CBTC, uses the IEEE 802.11 Wi-Fi, and its vulnerabilities include WEP, WPA protocol flaws, and radio frequency jamming, unauthorized DCS access, and location spoofing, where the attackers inject false position data to make the system believe that a train is somewhere, but it isn't there in a live railway. This is very dangerous, and ETCS relies on GSMR and balises. Using this off-the-shelf software-defined radio costing under $50 only, attackers can jam the balises signal, and this IMSI caches can clone the SIM communication, and ROS-based stations can perform man-in-the-middle attacks on the train control communication. Now the SCADA governs the power. It's a ventilation and environmental control system. It runs Modbus and DNP3 legacy protocols that are designed for isolated environments with essentially no authentication done. So attack vectors include protocol fudgings and credential stuffing and vendor backdoors and the lateral movement from IT to OT through insufficient of network segmentations. So what is common across all of the 3 is that they were designed before cybersecurity was a concern, and replacing 20 to 30-year infrastructures is very enormously expensive. That's why these vulnerabilities persist. Now, so what is actually attacking this system? We identified 4 threat attack categories. They are nation states and APT group. These are the most sophisticated one. We can take an example of Russian cyber attacks targeting the Ukrainian railways, and the most prominent recent example is Russian-Ukraine, obviously, because they are the part of hybrid like warfare strategy to disrupt the logistic railway system. The another type of threat is hacktivities, ideologically they are politically motivated attackers. For example, in the Belarus railway incident in 2022, where these hacktivities disrupted the train service to protect government policy. This is a clear example. And another is this ransomware gangs. Financially, they are very motivated. The Clarity reported that 54% of this industrial organization have been hit through the ransomware, and they are growing to 81% year on year at an average cost of about $4.54 million per incident, according to the IBM security reported. And another is the last one is this insider threats. They are very negligent and malicious employees with physical access and system knowledge whose actions are harder to distinguish from their behavior. So we classify this attack using the Strith and the Mitre attack customized for the rail domain. The real incident from 21 to 2024 was documented on the paper, including the UK Northern Rail ransomware, forcing manual ticketing, Belarus railway activities disruption, and Poland railways with 20 trains that were simultaneously halted via radio frequency attack, and Petersburg Port Authority tracking system was gone offline. So these are the 4 incidents, 4 countries, and 4 different root causes. This threat is not localized, but it has become global, persistent, and very much of evolving. Now, traditional signature-based tools can only catch what they have already seen. AI and machine learning learn what normal looks like and flag deviation, but traditional cannot do so. So that's exactly the capability of railway security net. So we compare 3 different models here. The support vector machine reads 85 to 92% of accuracy, useful when labeled attack data is scarce, and random forest and ensemble method hit 90 to 95% of accuracy with F1 score of 0.88 to 0.93. This was excellent for class imbalance, and CNN reached 90 to 96% for spatial pattern recognition. But the top performance was done by this transformer model, that is Rail FDNet, that achieved 97.46% image level accuracy, and this is known as the state of art. But even though this transformer received high accuracy, it has a low interpretability and high computational cost and no regulatory validation pathways. So it can be dangerous for safety critical application. So our conclusion was ensemble method offers the best balance for the real deployment today. Transformers are the future but need explainability. So the deployment challenges.
Excuse me, ma'am, you have 1 more minute left.
Okay, I will be fast. So the deployment challenge is, if AI works so well in the lab, why isn't it deployed everywhere? The conclusion is there are some of the compliance using real-time requirements, data and integration gaps, and regulatory and cross barriers. These are some of the most reliable deployment challenges. So talking about open challenges, we identified these 8 research gaps that are organized into prioritized roadmap across 3 time horizons from 1 to 2 years, what should be done, and 3 to 5 years, digital twin technology, multiple AI fusion, and the most important 5 to 10 years, autonomous defense system and safety security co-engineering. Now the conclusion is railway system faces the serious growing crisis like 220% attack increase, 75% DDoS, 54% of OT ransomware, and 11% of the cyber incidents. So the core vulnerability is the legacy infrastructures like CBTC, aged Wi-Fi, ICTIS unbroken, and AI ML offer the genuine promise, but transformer models needs more intuitability and high computational cost should be removed. So the path forward requires open data sets, digital twin environments, federated learning, railway-specific XAI, and unified safety security co-engineering framework. So this was the review from the cybersecurity challenges on railway system. Thank you so much for your attention, and I hope this gave you the useful picture of where railway cybersecurity stands today. Thank you so much.
Thank you so much, ma'am, for your presentation. So, do you have any questions?
Yes. Can you tell me how can a denial of service attack affects the railway operations?
So the denial of service attack, it basically sends the more traffic, network traffic, and it creates more of the fake traffics. Like attackers create the more fake traffics toward the network, and it disturbs the railway network. Like wire, it directly attacks the wireless link that creates the disrupt in the connectivity because of the more traffic, because of the more network traffic. Thank you.
Okay, just tell me one more thing. How is cyber security in railway different from cyber securities in traditional IT systems?
So the cybersecurity in railway is now the modern problem because in IT infrastructure we also use the signature-based AI ML approaches, and they are not sufficient because attacks are known in that. For example, some of the IT infrastructures uses this known attack surface. They uses a model where the attacks are known from the previously and they train data from like that. But in railway architecture we have the new evolving attack vectors like the future railway mobile communication system transfer migrating from the GSMR. So we need new type of evolving threats needs to be deployed and categorized based on that. So railway architecture have a real people, real incidents, and it should be in the real time. So I think this is more critical to analyze than most of the IT infrastructure because it falls under the safety critical application. Thank you.
Okay, Roshna, thank you so much.
Thank you.
Thank you so much, ma'am, for your presentation. Now I'd like to call upon our next presenter, Bhosle Rashmi Ravindra ma'am, to present her paper titled Digital System Integration as a Procurement Strategy for Sustainable Urban Metro Systems, Evidence from Indian Case Studies. Ma'am, you may please start presenting.
Yes, good afternoon, everybody. I'll just share my screen in a second. So I'll be starting with my presentation. Am I audible?
Yes, ma'am, you're audible. You may
Yeah.
start.
Thank you. So my paper is based on digital system integration as a procurement strategy for metro systems in India. And we have studied 2 Indian case studies. So I am a research scholar from Pacific University of Udaipur. And I'm also working as a procurement specialist in various infrastructure projects. So we'll start with what the paper is in short. So as we are aware that urban metro systems are a very important part of mass urban transport, and building urban infrastructure of such high value is important for the economic and sustainable progress of any nation. So we are here focusing on the challenges for procurement of urban metro infrastructure. And these challenges we are largely focusing from the ICT point of view, which are the systems of metro. So drawing on the statutory performance audits, we have done 2 comparative studies, and certain procurement strategies have also been studied. So in this contrast, we have shown what procurement models should be for metro systems. And the findings suggest that integration are a challenge. So system integration becomes the most decisive factor in achieving sustainable urban transit outcomes. So the urban metro systems are rapidly expanding in their network in India. So every metropolitan city in India is building their own metro systems. And despite the use of established technologies and international standards, the metro projects in India have been encountering recurring delays, cost escalations, and contractual disputes. So there has been a lot of research done on the delays in project implementation. So what this study focuses is that it addresses the gap by analyzing these delays in kind of how the procurement model impacts the system integration, delivery outcomes, and life cycle performances. So, sorry, the Metro systems are a combination of all of these major systems, which is the OCS, overhead catenary systems, telecom systems. Where there is no OCS, there might be third rail, power supply, the rolling stock, communication, and signaling. And it also combines with the station infrastructure of fare collection and electrical systems in the station. So what we have studied here is that the procurement structure defines how the interface will be governed. The interface between these multiple systems are governed. And there is a transaction cost exposure to procuring all of these systems separately, which will impact the delivery performance, and in long run it will also impact the life cycle sustainability if these systems are not properly selected and they are not working together in a proper way. So procurement strategy plays a critical role in governing these interfaces. In fragmented arrangements, these subsystems are allocated to separate contracts requiring coordination across organizational boundaries. And there are experts who will do this, there are consultants, there are client representatives. Still, all of this comes at a transaction cost exposure. So we have studied literature basically on construction delay studies and how procurement models have also been used in the tendering, infrastructure tendering. So empirical examination has been done for that also. So this is how the research has been done, the research design and methodology in brief. This analysis relies on secondary data because to study institutional design, we did not have to go to each institution. We used whatever was the publicly published data for the tenders. We have also used the publicly available audit reports published by the Comptroller and Auditor General of India, which is the CAG. And then we have done a comparative case study of two metro projects which were being procured in a similar timeline. Kind of say they were procured in both in a 2-year window. Within 2 years, these similar procurements were happening, which namely were the Chennai Metro Rail project phase 2 and the Mumbai Metro Line 6. So we'll start with the evidence from the statutory performance audits. The Comptroller Auditor General of India is the constitutional authority which is independent of the executive, and the CAG reports are placed before the parliament and state legislatures. These are not written by the project owners or consultants. These are independent audits. So CAG audits have been done for all metro projects, and we have taken from the major metro projects of Nagpur, Delhi. So the CAD audit documents the recurring delays, cost escalation, and underutilization of assets for all the projects. And they have identified certain things such as the weak project preparation, interface coordination issues, contract administration challenges, sustainability implications. So what we say is that the procurement strategy will impact all of these three: interface, contract administration, and sustainability implications. So the main case study which we have done are Chennai Metro and Mumbai Metro. So the Chennai Metro phase 2 data shows that there were total 36 system packages out of total 60 contract packages for the phase 2 expansion. And it can be seen that almost 50% of the packages are of systems. Systems are the ICT packages in Metro, right? Information and communication technology packages. So from governance perspective, absence of a designated system integrator meant that integration was treated as a coordination activity between multiple contractors. So as a result, integration testing commissioning is always going to be vulnerable to delays. So what has happened in Mumbai Metro Line 3 case study is that they originally had 6 systems packages, which they again retendered, combining only into 3 systems packages. So with the Mumbai Metro Line 6 case studies, the original packages were, the first one was rolling stock, second one was CBTC, telecom and platform screen doors, third was power supply traction, OHE plus SCADA, and fourth was station mechanical electrical, MEP. And fifth was lifts and escalators. Sixth was automatic fare collection, AFC. So all of these packages had interfaces with the other packages. For example, rolling stock will always have an interface with signaling telecommunication, platform screen doors, OHE with every package. The communications based protocol CBTC had interface with rolling stock, track, MEP, AFC, everything. So eventually, the revised contract packaging then combined rolling stock and signaling telecommunication. So the first two were combined as a package one. The power supply, traction, and station MEP and lifts escalators were combined as package two, systems package two. So what happens with this is that there are 30 critical rolling stock and signaling telecommunication activities. So by combining these two into a single package, these critical interfaces have been reduced and there is a single point responsible contractor for those interfaces now. Similarly, for package 2, there were 20 physical interface points which were also critical, and by combining these three packages, those physical interface points were eliminated. The AFC systems were kept separate and they now have interfaces with minimum packages because previously they will have to interface with the 5 other contractors, or rather 4 other contractors. Now they have to interface with only 2 contractors. So the case study interpretation shows that the procurement is a institutional implication. All other standards and all other conditions kept as same. If this kind of procurement strategy is implemented, what would be the outcome? And the implication shows that fragmented procurement heightens the risk of rework, idle assets, delayed commissioning, thereby weakening life cycle efficiency. Integration-oriented approaches improve predictability, accelerate service delivery, and strengthen environmental and social returns. So based on the cross-contract interfaces from the tender documentation available, the number of major interfaces...
Excuse me, ma'am, you have one more minute left.
Sure, I'll complete it in 1 minute. Thank you. So from the tender documentation available, these were the critical interfaces noted, and it can be seen that by combining the 6 packages into 3 packages, there has been 70% reduction in contract interface points. And also there has been a specific role of system integrator, which has been defined in the rolling stock package, who will be responsible for integrating the complete system. So internationally, the integration responsibility is embedded within the engineering, procurement, and construct design build contracts, or even in PPP frameworks, there is only one concessionaire. However, in India, it can be seen that there is a fragmented procurement. So compared to the trade-based packaging model, these approaches reduce interface dispersion, obviously, but in India, like we have seen from the case studies, there has been a fragmented procurement. So, however, comparing that reliance on a single integrator can also weaken competitive pressures and exposure to supplier underperformance. So it is a part where there needs to be more study done. Effective oversight, qualification standards, and performance guarantees need to be studied with that perspective. So I'd just like to close this by saying, although the empirical focus is metro rail infrastructure, these governance dynamics can be identified in other systems also, such as airports, smart grids, integrated water systems, which display similar system characteristics. In this context, procurement fragmentation will obviously create interface risk, while integration-oriented models can improve the efficiency. So these were the references for our paper. Thank you. I'm done. If you have any questions, I'd like to answer them.
Okay, please
Thank you,
tell
ma'am,
me
for your
which Indian
presentation.
metro.
Sir, do you have any
I'm sorry?
questions?
Yeah, please tell me which Indian metro projects you were examined as your case studies.
Chennai Metro Phase 2 and Mumbai Metro Line 6.
Okay, and what are the similarities and dissimilarities did you observe among these studies?
Yes, sir. So Chennai Metro Systems packages, there were 36 numbers packages as were published on their website. And for Mumbai Metro, these were the original tenders and then they were revised packages. So we have studied all these tenders.
No, I am asking about the similarities and dissimilarities that you did observe while you doing this case studies.
The Chennai Metro Phase 2 was an expansion kind of project, and Mumbai Metro Line, we have only studied systems packages. So there are similar kind in the length of the metro and number of stations. This was an expansion and this was a completely new project, but they were similar in length of this metro system and the number of stations comparable. They were comparable and they were procured in the similar timeline of the 2 years somewhere.
Okay, okay. What are the unique challenges of metro procurement in India?
So metro procurement in India, that is what there
I
are
am
different
asking about
funding
the unique. I am asking about the unique challenges of metro
unique
procurement.
challenges.
Yeah.
So procurement, I am a procurement specialist, so I'll be talking only on procurement focus. So procurement is based on the funding agency guidelines. So that there are different funding agencies for each metro. However, the funding agencies for Indian scenario, they have not insisted on using their standard certain things, and based on city specific things, they have given some relaxations. That's why fragmented procurement has happened in many places, and the standardized bid documents were not used, and that's why this is the challenge that we had identified.
Okay, Rashmi, thank you so much.
Thank you.
Thank you, ma'am. Now, I'd like to call upon our next presenter. Sir Armavan Rahadi to present his paper titled E-Health and Mental Wellbeing, User Engagement with Mental Health Content on YouTube. Sir, you
Okay,
may start
thank you.
presenting.
Okay, am I audible?
Yes, you are audible.
Okay, let me share my screen. Give me a sec. Yes, we're still loading. Okay. Hello, how about now? Can you see my screen now? Am I sharing anything? Or nothing yet? Hello? Can you all see my share screen yet?
No, sir, your screen is not visible.
How about now?
Yes, it's visible now. You may start
Okay,
presenting.
thank you then. So I'll just start quick. My name is Irman Rahyadi. I'm a faculty member from Binus University in Indonesia. In this presentation, I will present my study on the e-health content in YouTube. So my research interest is actually in social media and the society. So social media as a whole and now is we could say a primary source in health related knowledge. Every single one of the users want to know or want to explore a particular health issue they go to YouTube. So when we see that phenomena, I want really to see what is the content and conversation in YouTube about mental health. Okay, so there's this information, abundance of information. There's a lot of information that's produced by a credible content creator, or just sometimes it's not really credible. So this is what I do with these keywords or hashtag, as they said, mental health. I come across 370K channels, 1.7 million videos, and then methodology is to target it the mental health itself in the particular year 2023, and then excluded some of the not substantial material, so 200 videos remain, and then out of that I rely on the top 100 long form video, because the top one is actually categorized as the most relevant one. Okay, the next one, I'm looking at this data from the perspective of transactional affordance. So I'm looking at what the platform architecture say, what's the user experience, what the creator context, because the creator is especially in YouTube, a lot of individual and also a lot of a solid organization is creating content for different purposes. And in different side of the platform itself, the platform architecture, this concept of transactional affordance, they said that this platform is open up or democratize people to voice their opinions. But the algorithm of the platform itself setting up different structure. And the recommendation of, if you and me, for example, search something in our YouTube apps, we come to the different search result, because the recommendation engine is working differently based on our previous search, based on our IP address, based on our location, based on our interest. Interest that they said that they understand us better than us. Okay, and also from the perspective of user experience, how the audience actually engage with the content, with a particular content. In this particular one, in my research is mental health, that content. So based on that particular perspective, there's three pillars that I could say, three things that I could gather from the qualitative analysis. The first one is news coverage. The second one is event promotion. The third one is conversation format. Okay, so the news coverage. When during this time, the 2023, there's many people talk about that in a workplace, in a government institution. There's a lot of conversation about mental health across the world, in Asia, in Europe, in Northern America. And news coverage is actually the mirror of what people are talking about. So it's a lot of mainstream media in the US, WCNC, PBS, Public Broadcasting, NBC, the famous TV station, ABC News also from Australia. The duration of the coverage itself is 1 to 7 minutes, the duration of the video. We know that electronic media or mainstream media also having or organize their YouTube channel for multiple reasons and aims. So what I found that there are also, when I use the keywords mental health, more of the news coverage is organized by this news TV channels. The format is very clear. So there's an anchor, they deliver the news, and there's some conversation in the comment section. And some of the format also, they are quoting expert opinions, and they're also highlighting the cultural trends. The heavy use of hyperlink and call to action is very standard for them, because then they want to forward the audience in social media and YouTube to their own platform, to their own media platform. That's what I found in this first theme, news coverage. The second one, the event promotion. This second one is actually people promoting the events that highlight or they have the topic of mental health. Most of the content creator in this particular theme is NGOs or government organization. The duration is actually varied, and they are aiming to promote the campaign, to promote the event for sure. That's how and why event promotion is there in social media, right? To gather and to engage and to invite people to their promotion, to the events. So they are in this particular content, they are emphasizing on the dates, the location, and the speaker lineup to, of course, invite and to make people interested in their events. And the design is actually to get, sometimes the event is not only online events, so on-site events, physical events. So this is also within the themes. The next one, or the last one, is a conversational format. While the news coverage is actually inviting expert, sometimes expert is not in the studio. Sometimes they just quoting or they just reading what expert said based on their reportage. But this one, the conversation format, they put the long form, sometimes up to 3 hours of an event or of a discussion or webinar or online seminar or physical seminar. They hosted in YouTube as conversation format. They were talking as in a panel format or in one-on-one or a podcast. I'm sure you're all familiar with the podcast format in YouTube. So that's what they do. So the primary function is actually to highlight who's the organizer, the speakers, for the purpose of education. And it's actually a very
Excuse me, sir,
niche.
you have one more
Yes.
minute left.
Okay, so this is the last that I want to share, which is what is the actual format in here. Okay, I think that's all. Thank you, and I'm going to say that I'm open to any collaboration from you guys. If you can just message me privately, I can finish now. Is there any question, please?
Please tell me, how does YouTube algorithm affect mental health content visibility?
Okay, so nowadays in 2000 and let me stop share. In 2026 compared to 2020, the algorithm shift is actually looking to highlight the niche community. So when you said general viral video, general views movers, it's actually, and when you see one video, for example, viral or a lot of views, more than 1.5 million views, they are not recommending to others unless they are serving for a particular niche, either sports or a particular hobbies. Now it's in there. So while now people are not really talking about mental health, but now people talking about student mental health, or very niche, or a sport athlete's mental health. So that type of algorithm shift is actually affecting the actual topic of the conversation. That's probably the explanation in there, sir. Thank you.
And how do user interact differently with anxiety, depressions, and stress-related content?
Most of the time, users use for sure the comment section, right? But when you see user is actually commenting, it's not really what they said. There's one, I can give you one example of this interesting content from the one of the NGO in the UK. They're hosting the public announcement service. It's very good. Nice, very cinematic and professionally done. This short video. So if you got that type of viral, good video, but actually highlighting the topic that matters to society or to the community, is actually people are really engaged in that type of thing. For the reason of this is positive, is encouraging, is highlighting an important topic, important concern of the society. So people actually, the user is actually engaging and giving opinions on that particular one. So comment section, likes, it doesn't really matter. Now no, YouTube said that likes is not really matters anymore in terms of when algorithm is pushing that content to others, or pushing that content to a wider audience. Thank you.
Okay, thank you so much.
Thank you so much,
Thank
sir.
you
Now
for
I'd like to
the
call upon our next presenter. Here's Jamie ma'am to present her paper titled Early Mental Health Detection Using AI from Typing and Voice Patterns. Ma'am, you may start presenting.
Yes, ma'am. Am I audible?
Yes, you are audible.
Okay. My screen is visible?
Yes, you may start presenting.
Okay, thank you, ma'am. Hello, everyone. My name is Zahid Jamie. I am from Charosat University. Today, I will represent my paper on early mental health detection using AI from typing and voice. In our problem statement, mental health disorders, especially depression, are increasing rapidly and often remain undetected until later stages due to reliance on subjective methods like interviews and questionnaires. The major challenge in mental health detection is that it often happens too late. Traditional approaches rely on clinical interviews and self-reported questionnaires, which are not only subjective but also time-consuming and not easily accessible to everyone. As a result, many individuals remain undiagnosed in early stages. At the same time, important behavior signals such as typing patterns and voice characteristics, which can reflect a person's mental state, are not effectively utilized in existing systems. In this work, we propose a multimodal AI-based system that uses typing patterns and voice signals to detect early signs of mental distress. By combining text features using BERT and audio features using MFCC, our system improves accuracy and provides a non-invasive, reliable to approach for early mental health detection. In current system, we have reactive time detection for it, and we want a protective detection that we don't have. So we have an opportunity to use digital behavior like typing patterns and voice signals. These signals reflect emotional state and behavior changes. So our main goal is passive monitoring, real-time detection, and early intervention. So in objectives, detect early signs of depression using AI, extract text and audio features, combining both modalities and use multimodal learning, ensure explainability and privacy. In key challenges, variability in speech language, limited label dataset, privacy concern, and model interpretability in dataset and experimental setup. So we use diverse dataset that contain clinical interview dataset, audio recordings, and text transcript that has a label PHQ-8 score. If PHQ-8 which is greater than 10, then it is depressed, and which is less than 10, then it is non-depressed. So in implementation, we use Python, PyTorch, and Scikit-learn. In hardware, 16 GB RAM and GPU support. Here is our system overview. So we take input, text and audio features, we process them and extract features, and in output we classify depression or non-depression. So how the text features are extracted. So first the text features we do normalization, convert it into lower cases and remove punctuation and special character, remove stop words, apply tokenization on the split words. Tokenization split text into words using word tokenizer, handle unknown and rare words. We process using BERT embeddings. So process text we pass into the BERT model and BERT convert each word into the vector. So this vector captures meaning, context, and emotion of the text. So for an example, we have a text. I feel sad. So vector represents the negative emotion of this text. Sentence representation. So we use CLS token and average of all word embeddings. This give a fixed size of feature vector. In final output, we have a one vector that have a all feature map of text features. In audio processing, first we remove background noise and apply voice activity detection and normalize the audio. Purpose of this is improve quality of signals and then the second audio is divided into small frames like 25 microseconds window and feature extraction. We use MFCC, male frequency receptor coefficient, captures how human perceive sounds, extract frequency patterns and vocal text characteristics. In additional features, we we capture pitch, energy and speech rate. In pitch, how the tone was and high or low tone. In energy, loudness or high energy, speech rate, speed of speaking. These reflect emotional state. Frame level features are combined using a mean and variance, convert variable length with audio into fixed size vector. This vector is represent text audio features and which is used for classification. Multimodal fusion. In this, we combine both text and audio features and we use late fusion technique for it. It improves accuracy and robustness. In result, we have text model, audio model, and fusion model. For text model, we receive 92% accuracy. For audio model, 94% accuracy. For fusion model, also we receive 94% accuracy. In this, fusion model gives best overall performance, improved F1 score, more reliable predictions, and multi-model system is more accurate and robust. In conclusion and future work, we propose a robust multimodal AI system that combines BERT-based text feature and MFCC-based audio feature to achieve accurate and reliable and non-invasive early detection of mental condition. In future work, we focuses on extending the system with additional modalities like facial expression, applying advanced deep learning models, and enabling real-time deployment for more accurate and scalable mental health monitoring. Here, there are some references that we used in our papers. Thank you.
Here, which mental health condition can potentially be detected using typing and voice data?
Uh, we use typing and voice data, and then we compute THQ-8 score, and based on it we detect it is depressed or mental health condition, depressed or not. If THQ is which is greater than 10, then it is depressed, and THQ score which is less than 10, then it is not depressed.
And what is the difference between clinical diagnosis and AI-based detection?
Clinical diagnosis only use interviews and questionnaires and ignore the behavior patterns like text and voice patterns.
Okay.
So in AI model, we use these behavior signals.
Can smartphone and laptop data be used reliable for this purpose?
Yes, yes, sir.
Okay, thank you so much.
Okay, thank you, sir.
Thank you for your presentation. Now I'd like to call upon our next presenter, Aditya Novaputra sir, to present his paper titled How Omnichannel ICT Enabled Marketing Shapes Customer Engagement and Loyalty in Culinary Hospitality Services. Sir, you may start presenting.
Yes, hello everyone. So yeah, thank you for the opportunity for doing the presentation of our research paper. So this our research paper that we are going to present at the moment is talking about the how omnichannel ICT enabled marketing shapes in customer engagement and service loyalty in hospitality, especially in Jakarta. So yeah, I am the author of this paper, and we are also doing some collaboration with the several institutions for the tourism industry in Indonesia. So yeah, the paper would be conducting with the 5 sections. The first section would be discuss about the introduction and the research context. All right. Research context and the study discuss an empirical study entitled of how omnichannel and ICT enable the marketing shapes customer engagement and loyalty in culinary hospitality service, which is, as we know, that like the busy like in Jakarta, for example, like the Uber market at the moment. So the customer at the moment really concerned about how to get their memorable experience during visiting the some part of the restaurants. So they basically really concerned about how to investigate the things about the how the apps for browsings, the ordering payments, the loyalty and feedback as the new strategies in order to get the fundamental transformations as the customer journey that combine the digital and physical interactions. So the method of this study is usually we are using the quantitative approach, which analyzing the three big variables, which is the omnichannel ICT, and also as the customer engagement and the customer loyalty in the study. So we are using also the PLSM as the approach of the how to get the result about these research. So I'm going to do next. So the background of this study is basically rooted in the rapid digitalization of the culinary hospitality industry, where we know as the customer journey increasingly span interconnected digital and physical touchpoint. In chain restaurant context, at the moment, customer is basically commonly interact with the brands through mobile application. before and during, as well as the after and service encounters. So the interactions would be including like the discovering the menu, placing the orders, redeeming the promotions, managing loyalty rewards, and the providing the feedback. So the omnichannel strategies, as we know that they are widely adopted, and the previous study also conceptualized omnichannel primarily as a marketing activity focused on the channel presence on or promotional consistency. So the problem of the study that we find that we need to address in this research is the limited understanding of omnichannel as an ICT enabled service platform in high frequency culinary service, especially in urban market like in Jakarta. So consequently, the main purpose of the study is how to investigate how app-based omnichannel ICT-enabled marketing affects the customer engagement and service loyalty in chain restaurant in Jakarta. By addressing this gap, we know that the research will be contribute to hospitality ICT and provide practical insight for the restaurant operators seeking to leverage mobile applications as the strategic service infrastructure. So we are going to do next with the second with the second chapter, which is the literature review and research model. So we are using the three variables. The first variables we conducted with the omnichannel ICT environment marketing, with defined as an integration quality across service channel enabled by ICT. So in restaurant chains, mobile apps connected ordering and loyalty redemption with CRM and POS in every establishment. So the second variable is the customer engagements. It defines as the customer cognitive, emotional, and behavioral involvement via digital touchpoint. So the third one would be using is for the variable is the service loyalty that defines as the intention to continue, repurchase, and recommend it for the other customer to come. So there are the concept framework. So there are the hypotheses of this study. So the first hypothesis that we could try to conduct is how the omnichannel ICT enabled marketing has a positive effects towards the customer engagement. And the second hypothesis is the omnichannel ICT enabled marketing has a positive effects towards the service loyalty. And the third hypothesis is the customer engagement has a positive effects towards the service loyalty. And the last hypothesis is basically we're trying to find the indirect effect between all those variables, which is the customer engagement mediates the relationship between application-based omnichannel, ICT-enabled marketing, and service loyalty. So here we go to the research methodology. So research design and sampling. The study employs a quantitative approach, as have been mentioned before. So we are trying to propose the relationship between the omnichannel ICT-enabled marketing, customer engagement, and service loyalty. So we use the PLSM to measure all the effects between the variable. So the proportional sampling as the techniques was applied also as the participations require specific eligibility criteria related to the app usage. So we are going to use like deliver the questionnaires into the 150 filed respondents. A size considered that is adequate for PLSM analysis given the complexity of the proposed model and the method stability for moderate sample size. So yeah, this is the measurement instrument and PLSM. The measurement instruments, we use the Likert scale to ask the 5-point Likert scales from the strongly disagree until the strongly agree for the questionnaire use. The construct operationals, as I've been mentioned before, omnichannel ICT enabled marketing has the measurement as the indicators, which is the consistency and seamlessness, as well as the customer engagements is reflects with the cognitive, emotional, and behavioral interaction with the app, with the applications. And the last variable is service loyalty. So it's basically assessed with the continuous intention, repeat patronage, and word of mouth intention to the other people. All right. So here we go with the result and discussion. So yeah, the study is basically we propose to have the 150 customer respondents who basically divided into 58% who are female and 42% were male, with the largest age group being from the 18 until 24 years old. So in terms of the service mode, usage, delivery was the most frequently used features, followed by the dine-in and takeaway service. So most respondents reported using the applications at least once per month. So the measurement model evaluations demonstrate also the strong reliability and validity. So as we know that the indicators loading exceeded the recommended threshold from the 0.7 and indicate with the acceptable indicator reliability. Internal consistently reliability was confirmed through Cronbach Alpha and composite reliability, all of which was surpassed 0.7%. So convergent fidelity was established with the FVE, or average variance extracted, values above 0.5. So this result indicates that the construct were measured reliability and distinctly provide the solid foundation for structural model analysis. So here we go, the hypothesis that all the 4 hypotheses basically are supported. And the structural model result reveals strong support for all the proposed hypotheses, which, as we know, that the app-based omnichannel ICT-enabled marketing was found to have a significant positive effect on customer engagement, as well as indicates the higher integration, quality, enhanced customer cognitive, emotional, and behavioral involvement. A direct positive relationship was also observed between omnichannel ICT-enabled marketing and service loyalty, suggests that integrated app experience can directly foster loyalty by enhanced convenience and trust. So the customer engagement
Excuse me,
also,
sir, you have 1 more
yeah,
minute left to present.
sure. This will be the last, one for the slide. Yeah, okay. Then the service loyalty also has the 76.9% indicate the substantial explanatory power towards the others. So there are the conclusion and implications. So the conclusion is basically the app-based omnichannel ICT-enabled marketing has a meaningful shape the customer engagement and service loyalty. So the major implications that from the study is basically all of the establishment can be considered the application of the omnichannel as the ICT as the core service infrastructure. So they can basically focus on the improving the integration quality across service modes because the ICT can ensure the consistent promotion, seamless loyalty redemption, and personalized interactions. So as we know that this research also has the limitations, and the limitation is just only conducted in the one city, which is Jakarta. And the future research directions, could be use the longitudinal designs and behavioral uses data and expand to the multiple city, country, and so on. Okay, thank you so much for the attention. If you have any questions, please do. We will be open. Thank you.
Just tell
Thank
me
you,
how
sir, for
does
your presentation.
Yes, sir.
Just tell me how does omni-channel strategies enhance dine-in and delivery experience together?
Omnichannel, yes, it could be having the emphasize the great experience for the people before they want to find the restaurant. They basically, for example, they trying to find in the social media at the first, for example, like the content in the social media, and then they would, for example, in Instagram or TikTok, and they would be integrate into the WhatsApp, and they would be also integrate as well into, for example, into the admin from the restaurant as well. So they would be from one channel. It could be having some several channels that would be having the experience for the guests to revisit the restaurant.
Okay, thank you so much.
Thank you.
Okay, we can now move on to our next presenter. Mr. Stephen Eduardo Penza Morales to present his paper titled Prediction of Academic Performance of Postgraduate Students at the Technical University of Manabi using Big Data and Machine Learning Techniques. So you may start presenting.
Good morning. Um, Good morning to everyone present. I have the honor of presenting my research prediction of academic performance of postgraduate students at the Technical University of Manabi using big data and machine learning techniques. Introduction. The research was conducted at the Technical University of Manabi, where 23 online postgraduate programs were selected. This decision was based on the fact that much of the data generated is not being used effectively. Therefore, the objective of the study was to develop a reliable predictive model to determine student academic performance. Related work. The implementation of big data and machine learning application of digital platform, just BD such of research. In particular, studies conducted 2022 and 24 validate the use of the random forest algorithm for predicting student performance. These studies agree that the analytical value lays not only in prediction result, but also in the identification of specific factors that facilitate decision making. Methodology. Context of the study. For this study, data from the model platform and the academic management system of 23 online postgraduate programs of the university corresponding to the period 2021 to 2024 were used. Procedure. The study used the CLIS-DM methodology structured in five stages, starting with data compression and ending with model implementation. Results. Data comprehension stage. The initial analysis is composed of platform variables, which included 1,354 postgraduate students virtual mode and a total of 16,814 records corresponding to academic postgrad offers between the years 2021 and 2024. Data preparation stage. Data is clean. During data analysis, inconsistent data was detected. A total of 1,047 records were corrected to improve data quality. Additionally, outliers were found in some variables. These issues was addressed using winsorization, a technique that limits string values to a specific quantity. Finally, 2,814 irrelevant records corresponding to students who did not participate in the course were removed. Therefore, the initial data set consists of 30,974 valid records. Transformation and coding of variables. The categorical variables from the academic management system were transformed into numerical formats. Analysis and selection of features. After the cleaning dataset, the relevance of the variables was evaluated. For the interaction metrics on the Moodle platform, Spearman Rand's correlation coefficient was applied to determine its relationship with academic performance. The result revealed considerable positive correlation, heightened the sum of activity evaluation and their submission. On the other hand, for the demographic variables from the academic management system, the Chaker test confirmed statistically significant association with academic performance. With age showed the strongest association, followed by gender. Data balancing. Finally, the class imbalance was addressed as the number of students who passed exceeded the number of those who failed. To improve the accuracy of the models, oversampling and undersampling techniques were applied, generating three datasets. The original set with 13,916 to record. Balanced the undersampling with 3,430 to record. Balanced the oversampling with 24,419 to record. Modeling stage. After preparation, models were developed using the classification algorithms, utilizing the 3E dataset. Performance was evaluated by Venturi accuracy, sensitivity, precision, F1 score, and response time. The random forest applied with oversampling and achieved approximately 98% accuracy in the accuracy. Sensitivity and S1 score. With a precision time of 0.16 seconds, SG boots using undersampling obtain results close to 19 seeds present in the same matrix. With a precision time of 0.1 second, finally, the support vector machine model implement with oversampling achieve 93% accuracy across all metrics. Registering a prediction time of 35.88 seconds. Assessment stage. Internal validation. The model were trained with 70% of the records.
Excuse me, sir. You have 1 more minute left to present.
The models trained were trained. ¿Qué digo? The model trained were with 70 present of the record and validate with remain 30 present. Model performance was analyzed using confusion matrix comparing the actual labels with prediction. External validation. The selected implementation stage. The previous models were implementing in dynamic Power BI dashboard. This allows for visualizing the prediction along with demographic variables and interaction indicator. This integration enables a comparison of student behavior on the platform with their project academic performance. Conclusion, this study concludes with the development and implementation of robust predictive models to anticipate academic performance. The random forest and XGBoost algorithm demonstrate superior and consistent performance with metrics approaching 95%. Furthermore, academic success is determined by combination of prior performance, the quality of activities, the level of interaction, and socio-demographic profile. The findings allow the integration in model into Power BI metrics in practical tools for monitoring student performance and facilitating academic decision making. Thank you.
So, do you have any questions?
No, ma'am, no question at all. Thank you so much.
Okay, so there are no questions from sir's side. Thank you, Mr. Stephen, for your presentation. Now I'd like to call upon the next presenter. I'm Guel Escobar, ma'am, to present her paper titled Steward FM, an optimized association management solution utilizing the deflate compression algorithm for efficient cloud storage. Ma'am, you may please start presenting.
Good afternoon. Can you see my screen?
Yes, ma'am, it's visible.
Okay, good afternoon, everyone. My name is Joel E. Escobar. together with my co-authors Rosie Escobar and Demeline A. Monzon for the paper Steward FM, an optimized association management solution utilizing the deflate compression algorithm for efficient cloud storage. So for the background of our study, nonprofit organizations with limited budgets face challenges in digital management, including inefficiencies and high storage costs due to fragmented processes. Steward FM addresses these issues as an integrated web-based platform applying the deflate compression algorithm to reduce data and document storage. Built with a microservices architecture, Agile Scrum, and DevOps practices. It ensures modularity, scalability, security, and consistency. The system focuses on membership, events, donations, and budgeting, demonstrating that storage optimization can coexist with high software quality as validated by ISO or IEC 25010. So for the research questions, we have how do manual processes create inefficiencies in membership, event, and financial management? And how does Steward FM integrate these workflows? How does data fragmentation affect decision making? And how does Steward FM ensure accuracy and consistency? What challenges exist in financial transparency? And how do Steward FM's reporting features improve accountability? What storage limitations do organizations face on restricted VPS plans? And how does Deflate reduce storage requirements? How does adherence to ISO, IEC 25010 ensure software quality despite aggressive storage optimizations? So for our methodology, a developmental research design was used to create Steward FM, complemented by a descriptive evaluative approach to assess software quality. Agile Scrum structured development into 2-week sprints focusing on system modules and illustrates the utilization of sprints. To support scalability and modularity, Steward FM was developed using a microservices architecture, enabling the decoupling of major functionalities such as data compression, analytics, security, notifications, and reporting. This architectural decision allowed each component to operate independently, facilitating easier updates, improved fault isolation, and more efficient resource utilization. So furthermore, microservices enhance the system's ability to integrate with external services and adapt to the storage-efficient design goals of the project. And implementation was further strengthened through DevOps pipelines, which automated the processes of building, testing, and deploying system components. So continuous integration and continuous deployment practices were ensured that any changes to the code base were systematically validated and deployed with minimal downtime. This approach not only accelerated release cycle but also enhanced system reliability by reducing human errors in deployment. So for the results and discussions, Steward FM's modular microservices architecture bridges user interactions with secure authentication, validation services, notifications, and multiple SQL databases. We have automation for operational efficiency. The automation features embedded within Steward FM significantly enhance operational efficiency by streamlining core organizational workflows. Key processes including membership management, event administration, and financial tracking. They are fully automated to minimize manual intervention and reduce the likelihood of human error. Through automated membership handling, the system efficiently processes registrations, updates the user information, and manages status validations without the need for repetitive admin tasks. Similarly, event management is optimized through automated scheduling, notifications, attendance monitoring, and post-event reporting, allowing organizations or organizers to coordinate activities more effectively. And then financial tracking functions are also automated, enabling seamless recording of contributions, generation of financial reports, and monitoring of expenses with improved accuracy and consistency. So for ensuring data accuracy, centralized validated data eliminates redundancies and inconsistencies. Validation microservices enforce data integrity across all modules. The finance module provides real-time tracking of donations, expenses, and budget. Automated reports enhance accountability. And financial transparency, the finance management module provides real-time tracking of budgets and expenses. Automated auditable reports offer stakeholders clear insights into financial health, leveraging the same integrity checks used throughout the system to foster institutional trust. And optimization of cloud storage resources. This is the central technical contribution. Steward FM integrates Deflate into two areas: compression of data before storage and optimization of generated PDF documents. Compression results show 60 to 70% reductions in storage usage. And integrated workflows. The integration of DevOps pipelines and microservices play a crucial role in the reliable operation of Steward FM. These technologies ensure that different system modules communicate and interact seamlessly. For instance, modules responsible for certificate generation and data compression are coordinated efficiently, reducing errors and delays. Continuous integration and deployment pipelines allow updates to be implemented without disrupting or ongoing processes. Overall, this combination enhances system stability, reliability, and scalability across all operational workflows. So for our conclusions and recommendations, Steward FM effectively optimizes storage for resource-constrained associations through the integration of the deflate algorithm. Evaluation through ISO IEC 25010 resulted in a rating of 4.3, interpreted as very acceptable. The system balances high functionality, performance, and reliability while remaining storage efficient. It stands as a scalable model for digital stewardship in small organizations. So these are our references. And that's all. Thank you. This has been Angel Escobar for the paper Steward FM, an optimized association management solution utilizing the deflate compression algorithm for efficient cloud storage, with my co-authors Rosie Escobar and Demeline Imonzon. So to answer the question, if you have, let me call on my co-author, Ms. Rosie Escobar. Thank you so much.
Thank you, ma'am, for your presentation. Sir, do you have any questions?
Yes, please tell how is Deflate integrated into the cloud storage workflow?
Good afternoon, Dr. Kumar. This is Rosie Escobar, one of the authors. Well, the deflate algorithm was used basically before it goes to storage, making the specifically on the certificates because well in organizations such as ICTIS, when you are participants usually get their certificates from the system and then from the cloud, and before it goes to the storage, cloud storage, it is already the algorithm already reduces or optimizes the number of say bytes or kilobytes wherein it wherein this now these certificates now is are reduced to 70%, 70% of their usual allocated storage. Um, so that's where we use Dr. Kumar, the algorithm in the
Okay.
study.
Okay, then after compression, how does your system maintain data integrity?
Well, we used, of course, some authentication methodologies wherein the access of these certificates or other things that are necessary to for the participants' view. Basically, it's on the authentication part and some access levels wherein these were introduced in the system. Thank you,
Okay,
Dr.
one last question. Which cloud service model is Steward FM aligned with?
Pardon, sir?
I just want to ask about cloud service model that is to be aligned with your model, Steward FM aligned with.
Uh, well, we tried this in an organization, GIFMIC Incorporated, and we used we used a BPS for the. I hope we are answering your question, sir. We
No,
used
I am asking about the service model that is to be aligned with.
a service model.
Yeah.
Well, for this service model, I think Ma'am Escobar here discussed some microservices wherein we introduced the use of microservice model. I hope we are answering your questions here.
Okay, no
Wherein,
issue. Thank you so much.
thank you, thank
Thank
you.
you. Thank you so much.
Thank you so much, ma'am, for your presentation. Now I'd like to call upon our next presenter, Michelle Della Ventura Sir, to present his paper titled Computational Reconstruction of Missing Notes in Polyphonic Music Using Bigram-Based Entropy Models. Sir, are you present? Okay, I'm assuming Sir isn't present. And with that, all our presentations have come to an end. So I'd like to move towards the closing remarks now.
So, excuse me, I still have presentation to make.
So are you sure you're in this slot?
I received this in my email, isn't it?
So we'll get back to you in 5 to 10 minutes. Is that okay? I think this is not your slot.
Okay, may I make my presentation in 5 to 10 minutes?
Just a second, sir. Just a second.
Okay. My paper ID is 242.
Excuse me, sir. You will have to join in the next session, which will be in half an hour. So you can present at that time.
Half an hour.
1:30 p.m. IST.
Okay. Thank you so much,
Yeah,
ma'am.
sure. Thank you, sir. So with that, I would like to end our current session and move towards the closing remarks. I'd like to sincerely thank all the authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of us. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference, and we'll be happy to have you in the 12th version in 2027 as well. All the presenters would be getting the digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Lastly, I would also like to thank our session chair, Dr. Tarun Kumar, for chairing the session. Here is a token of appreciation to the chair on behalf of Team TIS
Thank you so much,
2026
ma'am.
and Global Knowledge Research Foundation and partners. Thank you so much, sir, for your valuable presence.
Thank you so much, ma'am.
Before finally ending this session, I kindly request you all to on your cameras for a quick snapshot. Can you please on your cameras? Yes, we are finally done with the session. Thank you all for your valuable presence. Stay safe and take care. Thank you. You may now leave the session.
Thank you.